My name is Santiago G. Romero. This is my final design of wireless project for ITT 370 for Professor Tim Collins. We're going to start off by going over my network design. I used Draw.io to complete the design since it was free. So I'm going to start off with the beginning of the network, which will be our modem provided by our internet service provider, which will connect the router, which will then connect to firewall before it hits the devices on the network. We'll go over here to our first switch. I separated the switches to make it a lot easier to handle network bandwidth and for this purposes. So we have our network switch. That's for the wireless network. We have wireless connection, which then connects to the campus network connection using access points as a mesh network. And here we have the devices connected to the network as we see here. Our next switch is for servers. We have our VPN server for people that are offsite to have to connect to certain websites or even network drives that will connect using the VPN. We have our mail server, email application server, and our Active Directory server. Then we're going to go on to our final switch, which is the switch for all hardline connections, which would be our hardline PCs, and here's an example of how it would work. Of course, this might be per building, depending on how many buildings the company has. So this design will work for each building. Okay, let's move on over to our designing our quality of service design. We have a plan for wireless IP phones. It will mostly consist of the wireless handheld devices, a router, modem, and a VIA desk phone. A VIA desk phone application for desk phones, as well as Wi-Fi phones that use a VIA. Next, we will be testing our applications to check to see if they are compatible with Wi-Fi. Some applications run really slow when you connect to Wi-Fi. Maybe sometimes we have issues watching videos or even connecting to certain websites. Next, we're going to move on to designing our wireless network. The type of security we will have in place. We will follow these key points. Access control. It regulates who or what can view or use resources in the computing environment. That will be on campus or off campus. That's where the VPN is important. Physical access control limits the access to campus, buildings, room, and physical IT assets. You don't want any users coming into your server and moving things around, pretty much. Authentication is the process of identifying a user and by user presenting credentials. Most of us have, for example, here at Grand Canyon, we have our username and password that we use to log into our DCU websites. Antivirus software is to be installed on all computers, servers, and switches, and any devices to protect it from malware, such as viruses, computer worms, spyware, botnets, rootkits, and keyloggers. Anti-malware is to detect and remove new and sophisticated malware strains and to strengthen security along with antivirus. This works hand in hand with the antivirus software. One's pretty much for detection and one's for removal. Email security to prevent malware and spyware as well as phishing attacks. I know Outlook has a phishing alert where if you receive an email that's not recognized, you can hit the button and it goes to the IT department for evaluation, and then they will let you know if it was a phishing attack or a legitimate email. Firewall installation, security devices that monitor incoming and outgoing network traffic, and it decides what to allow and what to block depending on the security rules. Also, another key aspect is user awareness. Knowledge is pretty much the key in preventing a security attack in most cases. Most of them are just phishing or doing reconnaissance on users on how they can get them to give them valuable information such as usernames and passwords. Our access points are vulnerable if they're not properly encrypted and secured. To prevent an installation of rogue access points and monitor our own access points, we install wireless intrusion prevention systems to monitor our own Wi-Fi access points, and as well as somebody gaining access to the facility and installing their own access points. Somewhere where we cannot detect it. As we can follow these simple rules, this is how we can prevent rogue devices on our network. Testing our security gaps. Security gap measures policies and procedures to verify whether they meet compliance requirements and industry best practices. Security test is a way to identify the threats in the system and measure its potential vulnerabilities, so the system does not exploited by hackers or threats. You have to test all your devices, servers, switches, firewalls, applications, um, any other resources used for potential, vulnerabilities. For example, some websites hold on to your password, they cache it. Maybe that's something that can be disabled. That way, credentials are not kept by the web browsers. Somebody logs on to an unknown device, uses their credentials, and somebody now has that information. They may not use it, but then again, they can be hacked and give that information to somebody else. You have to identify your risk. Workers, interns, they use poor judgment, again, on replying to emails that are phishing attacks. Perform a risk assessment, test the network and application software personnel. For personnel, mostly training. For software, is keeping up to date with security patches and the most available software. Network, it's important to update devices as needed. End of life devices should no longer be used. You should consider that most businesses allow administrative employees to take devices home to work from home. Businesses should prevent this by, encrypting devices, following security protocols when connecting to wireless networks, encrypt the device, BitLocker device encryption enabled on all devices, install virus and malware on devices that are taken home, having the latest updates and security patches for software and the device, and authentication login devices. They have to use their credentials to log into the device as well, and also have the devices added to the domain. Now we have here some guidelines uh, for the research rules for HIPAA. Uh, you have to make sure you follow those. If you work in a hospital, this is very important. Keep patient information private, as well as Children Information Act. Payment, if you accept credit card payments, you have to have security measures for that. And also Federal Information Security Management Act, FISMA, requires federal agencies to be compliant with network security. And ISO 27001 is the international standard for information security management. Those are just some key points to keep in mind depending on where you work at. So our next part will be our final phase, which be our design and things that we need for our network. Let's start off with the cable. Since we're going to be upgrading the existing network to have wireless access points, we're going to need cable to connect those access points. Some access points could be wireless, but I figured having them connected to a network would speed it up instead of relying on Wi-Fi access points just as a standard. This will also help with connectivity and monitoring devices on the hardline. So we have 1,000 feet of Cat 6 for $96. And we're going to be using our product here, which is our router. We're using the Cisco ISR 4321 router. Two ports, two slots, rack mountable, new factory, sealed in stock. So this high performance integrated router runs multiple concurrent A-Twin services without your data, without slowing data throughput. Access points, we're going to be using Cisco Air wireless access point with internal antennas. They're each $600. They're kind of pricey, but in the long run, it's going to pay off. We're not going to have any network lag. And our firewall and VPN support. We're going to use the Fortnite FortWire Wi-Fi generation package here. It's $353 for the Wi-Fi. For the VPN, but it's also a firewall, VPN, and ISP and application control with web filtering, antivirus, anti-spam, and has many other features. Now, the VPN licenses. VPN is not free, so you have to get it from a vendor to supply you the licenses. So we're going to go with Cisco VPN software Meraki. This can also be used on handheld devices such as iPads and phones. Of course, this is for 50 users. The company I was doing had 196, so 100 licenses should be enough. So we put that in the plan. The next part would be the network Cat-C connectors. We have the cable, but we also need the connectors to complete the cables. They're $25 per pack of 100. Also, a testing kit and connect toolkits. This has the tester, the crimping tools, the wire strippers in case. Ordered 2 kits for $60 each. We have the servers that we're going to be using. We're going to go to HP ProLiant server, 16 gigabyte RAM and 4 terabytes of storage. It's about $964. It features such as redundancy, reliability, and manageability. This server delivers the right size tower and performance, and it's expendable. That covers a wide area of applications and workloads. Also, we're going to be ordering some Cat 6 cables. Pretty much Cat 6E patch cables, 3 footers. Just in case you need to finish connecting patch cables in the server room. Also, we might have outdoor access points available. It is a military manufacturing company, so they might require access points outside for testing. So we're gonna install a couple. Cost us $159 per year. They also work wireless internet in or out, so maybe we can place them inside the building to feed network outside. And our products, we have the cable, the access point, the firewall, the VPN software, 2 Cat-C connectors, the toolkit, the server, the patch cables, outdoor access point, for the total cost of $24,744 for a new wireless network. Thank you.